As part of the vector tiles work package, the Gnosis Map Server was improved into an efficient dynamic vector map tiling service. Simple extensions to the web feature service were proposed to enable its use to deliver features as vector tiles. As an example, the regular QGIS client is already capable of accessing the produced tile vector maps being served through WFS. The vector processing pipeline for Gnosis was significantly improved during the course of the testbed. The first experimentation was done with the Natural Earth dataset, 1 to 10 million public domain dataset with global coverage. This allowed testing for particularities at the date line, the poles, and at very large scale. Further testing was done with the OpenMap local data from Ordnance Survey at a much more detailed 1 to 10,000 scale, while still covering all of Great Britain. Performing tiling at multiple zoom levels allows visualization of datasets with both high resolution and very large geospatial coverage, with the possibility to transition anywhere between a global and a local view. The style layer descriptor and symbology encoding style sheets provided with it were used by the client to properly style the map. As vector data does not itself have an inherent consistent appearance, an extension is proposed to associate specifications of styles with the layer being served so that clients can readily present the data as intended by the provider. Vector tiles allow to achieve consistent visualization performance and to maintain roughly equivalent bandwidth regardless of the scale and geospatial extent of the data. A tile-aware client can gain performance by caching individual tiles and can precisely communicate the desired scale of the vector data being requested. Tiling of geospatial data makes it possible to manage arbitrarily large datasets. An objective for these extensions was to minimize the amount of changes required to existing clients and services to support transmitting tiled features. The production of tiled datasets is an involved process requiring manipulating the vector geometry in various ways, such as generalizing the data to be suitable for a larger scale and splicing it according to a tiling scheme. In the process of performing these operations, great care must be taken to avoid introducing topology errors, such as self-intersecting geometry.